Hello everyone, my name is Shelby and I'm going to be talking about Lab 3 circuits for Physics 2. To start for this lab, I'll introduce our main goals. So we had 3 main goals: to understand current and voltage in circuits with resistors and capacitors, and then we had to measure the electric current and potential difference across the circuit and then find the time constant using experimental values and compare it to a computed value. So for my results, I saw that we were able to calculate both the wire resistors and the ammeters was respectively. It was respectively for the wire it was 0 ohms. For the resistor it was about 28 ohms, and then for the R100 resistor it was 102 ohms, and for the ammeter it was again 0 ohms. I also had noticed that the charging and discharging times of the capacitor were roughly the same, and the experimental time constant was found to be 5.89 seconds, and the calculated time constant was roughly 6. Some important concepts that we used to discuss was some physics principles dealing with Kirchhoff's voltage law and Kirchhoff's current law, which is respectively the loop rule and the node rule. And then we had to understand that using the resistors that we had in order to find the currents, with that I is equal to delta V, which also equals IR. And then I had to find the time constant with this equation that is in the bottom right hand corner. For the experiment, we had part 1, which I had to deal with a circuit with 2 batteries and 2 resistors and 2 ammeters. And then I was able to determine both the experimental value of the current and compare that to the actual value of the current. The system was just the circuit, and then the surroundings was everything outside the circuit. But in an ideal situation, we would have used the software and wouldn't have to worry about anything on the outside. Then we were able to calculate the change in voltage across the circuit. So through the battery, it gains 3 volts, and then 3 resistors, it loses voltage. Like the C to D, it's the 0.96 voltage. And then for E to F, it was negative 2.04 voltage. And then we applied this on a graph to show how the voltage changed throughout the circuit. And then from this, we were able to determine the resistance of each component of the circuit. And then we saw a slight change from 48 ohms to our 47 resistor, and then 102 ohms to our 100 resistor. And then this could be just precision of the ammeter and or like rounding calculations when I was doing the calculations. Then we had part 2 of the experiment, which was an RC circuit, and I pretty much had the exact same case, but this time I had a 9-volt battery and a 10 ohm light bulb, and then a 0.2 F capacitor, and then repeated this again with the 20 ohm light bulb. And the procedure was to measure the timing takes to charge and discharge the capacitor. And then looking ahead, there's going to be some sources of human error when doing this experiment. It could have been stopping the stopwatch at an incorrect time and not getting the exact seconds correct. From the previous slide, I was able to see that the charging and discharging time was approximately 16 and 15 seconds. The charging time and discharging time for the 20 ohm bulb was about 29 and 28.5 seconds, which shows that there was an equal time when charging for the light bulb, but doubled the time when I doubled the resistance. So from this, I was able to plot the change in voltage on a graph every 20 seconds, and then my slope was found to be negative 0.1724. And then with this, I was able to find the experimental RC, which is the time constant. So we put 1 over the slope, and then I found that it was 5.8 seconds, which is approximately equal to the 6 seconds that was my predicted time constant. For our 2 what-if questions, for the first one, I answered it by saying in real life, the ammeters have some resistance, which causes a slightly lower current to flow through the circuit compared to an ideal ammeter used in the simulation. So basically, when there's unlike the ideal case, which is what we did, when there's no voltage drop, then the real ammeters do introduce a small one across the different terminals. And then for the second what if, I said that the capacitor would have charged instantaneously, it would have charged instantly. However, in reality, the resistance causes the charging process to take a bit longer, although it's still pretty quick overall.